In this video, I'll calculate the 95% confidence interval for a population mean based on a sample of 6. So this is the example from the data from our one sample t-test example. So when we calculated the mean of these sample mean of this data set, it was 3.7143. So that's our sample mean. So we'll want to calculate the 95% confidence interval, which we'll do by taking the sample mean and separately adding and subtracting the product of our t-value that corresponds to the two-tailed version for the alpha, that is 0.05. So that would be 1 minus 0.95 to determine which alpha, which t-critical value to plug into the equation, times the product of that t-value times our standard error of the mean. So we have the sample mean. We can calculate the standard error of the mean by taking the long route. If we just had the raw data, we could take sum of squares, turn that into the variance, turn that into the standard deviation, and turn that into standard error of the mean. So let's pretend that we hadn't already done those computations and just do it from scratch. So first, to get the sum of squares, we need to get the sum of the squared x's minus sum of x squared over n. That's our first step. So x's squared are 25, 16, 36, 4, 1, 9, and 25. And if we add all of those up to get the sum of the squared x's, we would get 116. So our sum of squares value is 116. Subtract the sum of x squared, which is the sum of x in this problem is 26. So if we add all of these individual data points up, we get 26. We would take 26 squared over n. N here is 7. So to get the sum of squares, we work that out and get 19.4286, which if we want the variance, we simply divide that by n minus 1 for the sample variance. So 19.4286 divided by 6 gives us a sample variance of 3.2381. And to get the standard deviation for the sample, we can take the square root of the sample variance, which is 0.2381. The square root of that is 1.7995. And then finally, to get the standard error that we need to plug into the confidence interval equation, we divide that by the square root of n, which is 7 in this problem. So our standard error, as it was before, is 0.6801. So we're going to plug to get the lower limit of the 95% confidence interval. We're going to take our mean, our sample mean from this problem, which was 3.7143, going to subtract for the lower limit the t-value that corresponds to the lower end of the 95% confidence interval. So we'll need to put in our degrees of freedom, which here, since our sample size is 7, our degrees of freedom are 6. We're looking at a 95% confidence interval, so 1 minus 0.95 will give us the alpha level that basically fences off in 90% of the 95% of the distribution, and fences out on either side 2.5% of the distribution. So we'll want an alpha of 0.05 for the 95% confidence interval, and we'll focus on the two-tailed value of 2.4469. So we're subtracting the product 2.4469 times the standard error. So that times standard error, which we said was 0.6801. So only the product of those two, which if we multiply those together gives us 1.6641. So our lower limit of our 95% confidence interval is going to be 3.7143. Subtract 1.6641, which will give us a value of approximately 2.05. Our upper limit is going to be 3.7143, our sample mean, plus the product of our t-value that fences in 95% of the t-distribution, and product of that and our standard error, which we already calculated as 1.6641, and we get our upper limit for our 95% confidence interval as 5.38. So our 95% confidence interval for this population mean based on the sample mean that we have and the standard error and the desired level of confidence is 2.05 to 5.38. So what that basically means is this is our best estimate at the 95% confidence interval level of where the population parameter, or the population mean, that corresponds to our data, our sample mean and our standard error and our desired level of confidence. So this is our best guess of where the population mean actually is. So instead of having a point estimate for the mean, we instead have an interval estimate for where we think the population mean is based on our data.